program. So Prayas and INYAS, they have joined hands together for a Teach for Science program, where undergraduates and graduates are being mentored by graduates and other faculty members from across India. We have about 30 to 40 mentors and mentee in the program. And a part of this program is this lecture series, which INYAS, I'm really grateful that they are providing such a nice platform. We have about two previous sessions, and this is the third one. Thanks, Suganda, for agreeing for interacting. And the topic really seems very interesting. So I'm looking forward to it. Before that, I would like to introduce our speaker for today. Dr. Suganda Maheshwari is working as Assistant Professor at Department of Mathematics at IIT Roorkee. She completed a meritorious journey of graduation, post-graduation and doctorate from Punjab University, Chandigarh. I would like to know which year, because I'm also Punjab University alumni. During her graduation and post-graduation, she was recipient of NBHM scholarship awarded by the Department of Atomic Energy, India. She was also awarded prestigious CSIR Shyam Prasad Mukherjee scholarship during PhD. And for her postdoctoral research work, she obtained DST National Postdoctoral Fellowship, following which she became an inspired faculty member, and I am assuming it's at IISER Mohali. Yeah, so I was also there. I would like to know which year you were there. A number of national and international publications go to her credit, which also include a white paper entitled Career Challenges for Young Independent Researchers in India. I took a glance of the paper. It seemed very interesting yesterday. It was in Current Sciences. I saw that. So that was an interesting piece of read. She's also an author of a software package. She has been invited as a speaker for various national international conferences. She's currently serving as a core committee member in Indian National Young Academy of Sciences. And along with her research in academics, she's actively involved in various outreach activities in different roles. So thanks, Suganda, for being here and for talking to our students who are part of this Teach in Science program. And I'm really looking forward for your talk today.
Thanks, Bindya, for elaborated and kind introduction. It's such a surprising thing that though we have two common institutes, but we are still meeting virtually. So I joined in 2006, I joined for my BSc at Punjab University, and I was there for almost a decade. So I did my graduation, post-graduation, and then PhD. And in 2016, I moved to IISER Mohali, and then I spent almost 7 years there. And now I am at IIT Roorkee. So thanks for the invitation from Prayas, and I'm very happy to see people doing outreach for the good of students, and that is one of the mandate of INYAS, and that's where our common interest is. So it is my pleasure to be here, to be speaking to people, and I hope my lecture motivates students to take up mathematics. So I was told that we have a mixed audience. Not all students here are mathematicians or mathematics aspirants. That is why I chose a topic which I thought could be relevant to almost everybody, from any section of the students to mathematics aspirant or mathematical researchers. So I have tried keeping it least technical and most relevant to daily life and understandable for most of the audience. But still, if some part is unclear or anything which calls for discussion, please feel free to ask me. If it hinders your understanding, you can always interrupt. Otherwise, at the end of the lecture, you're most welcome. So I'll share the screen to get going. Let's not keep students waiting much. And if it is okay, can I put my video off because it is hindering my view for the screen?
Definitely. Yeah.
Okay. Wait, I'm sorry. This is... wait. Okay, so basically, roughly speaking, I am here to advertise my subject and express my love and passion for the subject that I am studying, right? So that is why mathematics, like why to study or why do I study, why I want everyone to study is what I would like to express. So what do you think of, what do you imagine when you hear the word mathematics? What all things come to your mind? So you see a picture here where students have some formally written over here, some symbols are there, and this is a general notion that when we talk of mathematics, we imagine numbers, we think of calculations, we think of computations, and then we relate it to certain formulae, right? Many people associate it to estimation also. Then it leads to problem solving. That's a very important component of mathematics. Then puzzles also, many puzzles are around mathematics. Then you can think of some symbols, for example square root, and then all sort of symbols which we work with in mathematics. And then you can always think of some figures related to it. Geometry is a very essential component of mathematics. And so all these things are the first things that appear to your mind when you talk of mathematics. Everybody has taken this subject at school level. But now I would like to give you what is the precise definition of mathematics. How do we define mathematics firstly? Okay, so first one here is Wikipedia definition, which says that mathema stands for knowledge, for studying, for learning, and they define mathematics to be area of knowledge which includes numbers, formulae, related structures, shapes, spaces in which they are contained, and quantities and their changes, right? We can elaborate this definition to have more of understanding, but this syncs well with the things that we thought of, which mathematics is related to. Now, I would also like to present my version or my understanding of the subject, being in the field for probably more years than you. Mathematics for me is a subject which has its own language and symbols. Okay, this is altogether a new world. You cannot feel these symbols, you cannot feel this language in the physical world. You cannot really touch them, you cannot really have that sense of feeling. So it is a sort of virtual world. Okay, but then I'd say that this world is beautiful. This is a beautiful world in itself, and it is relevant for all spheres of life, though it is not part of physical world, but yet you can feel its importance in every sphere of life. And the remaining of my lecture will be to justify this definition of mine or this understanding of mine. Why do I say this thing? Where all do you see mathematics, and why should you study mathematics? Okay. So the very first thing, I mean, in everyday life, where do you see mathematics? Food is a very basic necessity. You need to have food for the survival. Okay. Now, for the food preparation, the volume estimation, the amount of food, the components, ingredients that you need to take, they have to be in a certain ratio. Otherwise, it will be a mess, right? So there is where mathematics come into picture. For a 1 kg of thing, if you have to add 1 spoon of something, and if you take 2 kg, you'll go by the ratio to add 2 spoons of it, and so on, right? So a very basic thing, you do use it in everyday life. So estimations and of volume, quantity, they are not just restricted to food, but in other things also. For example, if you have to wash clothes, how much detergent you have to take for that, depending upon the quantity of clothes. So that's a very basic thing. Implicitly, we are using it even without realizing at times. Okay. Communication, I would say a modern day basic necessity. You cannot really survive without communication. You have internet, you have phone, and everything goes more or less around it round the clock. Okay. So the data transmission that takes place, there is a strong mathematics backing it. What are the essential components of communication? One thing is you look for quality. The video call that you do, how blurred is your video going on, or how blurred are the pictures that you receive, or how fine they are. That is the quality that we talk about. Speed, another very important component. You talk of the time lag, right? And also, the speed with which data is transmitted is important. And above all, the security of data is very important. Okay, so encryption decryption is related to the security component, and all this communication, all this data transmission is based on algebraic coding theory. Okay, so that uses very basics of linear algebra, group theory, and understanding of some high mathematics to come down to this communication that you have. The OTP that you receive every day for the transactions, what is that meant for? That is meant for security. And how these codes are generated, there is a mathematics behind that. Okay, number theoretic functions are used for that, and so there is a whole a lot of algebra associated to this. Then you can see its application in travel and transportation. Now, how in travel and transportation? One thing is very basic thing: speed, distance, time concepts. Okay, in how much time where you will be able to reach somewhere. But then it can also be applied to more technical things. For example, okay, let me put a very simple example. For example, there is a courier boy and he has to deliver things to 10 different places. So one thing is he can look for best possible time, or he can look for best possible distance that he will have to cover, the minimal distance that he will have to cover to deliver the things. So what should be a roadmap for him, right? So such problems are taken up in the optimization theory, in the linear programming. So there also you see the role of mathematics. So this also helps you drawing best routes. For example, the routes of trains and buses also can be devised using mathematics, because they have multiple stops, not one. Okay. And then finances. Of course, no getaway in this materialistic world. Everything revolves around money. So simple budget management, of course, is simple basic mathematics. You use it in everyday life. You have this much money, how much you want to spend, and things like that. Then there are also other things where you see use of mathematics. For example, there are luring schemes in the market. They show you like low cost EMI or no cost EMI, or they offer you various discounts like 50% plus 50%. That does not count 100%, right? So it needs mathematics to understand what is the actual percentage of discount that you're getting. What is the benefit that you're getting in EMI actually? This also plays role in your investments and savings. For example, you must have heard of the insurance policies where they say in this much time your money will double or something like that. So calculation of interest and having an understanding, is that scheme really worth, or how much profit or loss you're going to have in this, what is the appreciation you're going to have in something, or how is your thing depreciating over the time. All these calculations again come under mathematics, and in fact insurance companies use mathematics for the analysis of how much should be how much is the rate of some accidents or things like that, to come down to what should be the value of certain policies. Okay, so you see, we can start from a very basic thing, purchasing a thing and using a simple arithmetic there, or we can go up to analysis to have understanding of what should be the policy that is going to benefit customers. Or so there is a whole range over which one can one can have understanding of this subject. Okay, and then apart from these, you also see mathematics in architecture, right? That's a very basic thing. How much space do you have, how do you utilize that space? So in construction, in interior decoration, this is used. It's based on area and volume calculations to calculate and estimate proper layout of any room or building. And such concepts are of course important part of mathematics. For example, you see the construction of stairs. So what length or breadth should be kept? that decides the effort that you will need to climb it up. And also, you need to take care of the space which is available to you, right? Well, you must have seen bridges and you must have observed there is this triangular kind of structure that you see every now and then. So, there is a reason why you have this triangular structure and not rectangular or any other shape. You see these yellow dots which are marking up a triangle, right? So, why is this so? Triangles are used in bridges because they evenly distribute weight without changing their proportions. So that adds to the strength of bridge. They are more efficient to have more of the weight. Okay, so when this force is applied on a shape like a rectangle, it would flatten out, but not in the case of triangle. And in fact, for this thing, it is also said generally that triangle is a strong shape. Okay, and on right hand side you can see a figure which is drawn that if you have this load, it distributes it evenly to the two sharp ends here. Okay, in fact, I won't elaborate much, but you can use the concept of mathematics for the construction of flyovers. You see the slope which flyover has. Sorry. Okay. So all these things play a role in the construction, in the architecture, in almost everything. And one more example of architecture is the cooling towers of nuclear reactors. You must have seen that nuclear reactors have cooling towers which are of this hyperboloid shape. But then, what is the reason? Why do we always have it in this form? The middle picture that you see that has the detailed structure of how various components of cooling towers are there, and this hyperboloid form is in fact an economic solution. Anything else is going to be far more expensive to design, to validate, and to build up, right? So right hand side, if you see, is a structure which you have here. So this is the standard design that you have for all cooling reactors, and it is structurally sound. It can be built with straight steel beams. If you see the steel beams which are used here, they are shaped, and for a given diameter and height of tower and a given strength, this shape is optimal. This requires less material than any other form, right? So I'll move on to the next definition. Many of you must be sports lover here, either as a viewer or as player yourself. So mathematics is definitely clearly related to sports. So you see some pictures depicting this. For example, in the first one, how should footballer project the football so that it actually makes a goal, right? This parabolic trajectory you see for the basketball to make it actually enter into the basket. And then you have the angles for athletes to have an optimal range of the throw that they are going to do. So all such things do come into picture with mathematics. Also, you must have seen the route, the trajectory which is made for athletes to run. Okay, so that difference is left, that so that they do not start at the same level. They start at different places so that there is no benefit given to anybody over somebody else, right? So whether discussing players statistics, a coach formula for drafting certain players, or even judges score for a particular athlete, mathematics is involved. And not only that, the concepts like likelihood of a particular athlete or team winning, that is a mere case of probability. And to maintain equipments which are there also mathematics is used. Then the calculation of like how optimal performance of some sportsmen can be taken up, keeping into account the endurance, the speed, the natural factors. So all these things are taken into account to have the best performance, and all these are applied when you go to when you reach a certain level and when you are looking for a competition. Every factor matters there, and such calculations are done by coaches as well as sports person to have the best output. Okay. Again, another field, music, right? Most of us enjoy music. Now, music is also closely related to mathematics. One thing which is common to both of them are patterns. Mathematics has close connection with patterns, and so is the case with music. So they are already connected, and we usually use numbers and mathematics to describe and teach music. Those who have professional training must have realized this thing. And understanding fractions and ratios helps to understand the rhythm of musical notes. All of the notes and rest in music, they have numerical connections as because each have a certain amount of beats. So it is important for musicians to understand the value of these fractions and notes so that they count the music correctly. You must have heard some well established musicians saying that we have applied some mathematics to mold the beats or mold the music. So there is some kind of calculation which is related to compose music. Okay. So these are Pythagorean ratios. In fact, Pythagoras was one of the mathematicians who realized this thing, that if you have a string, what kind of vibrations it will create, and if you have that spring, how will that vibration change, and then if you have threefold or fourfold, such kind of things, they were recognized by Pythagoras, in fact. Okay, mathematics and computers. This is something that is natural for you to have a feeling of that this is related. All computer science professionals, they need at least some knowledge of mathematics. Okay, so at their core, computers are numbers. Computers have numbers, and just think of the word computer, something that computes. Even if you use your laptop to send emails, more often than to balance your bank account, there's a math going on inside your machine. Because math is a foundational part of computer systems, every programmer and computer scientist needs to have basic knowledge of mathematics. And the type and level of mathematics you need, that depends upon what areas of computer science you want to work in, right? So they generally computer scientists generally use all different types of mathematics. Those who work with advanced algorithms and matrices, like the kind of involved in image recognition. Okay, you have this image recognition needed for medical diagnostics, for examples, that needs to understand some concepts of differential equations. For example, if there is a testing, if there is a blockage in artery which needs to be detected or something like that, so there is an image recognition which is done. So for that, the differential equations are used to have analysis of that or understanding of that. Okay. The binary number system, which uses digits only 0 and 1, which you must be familiar with, to express all mathematical concepts. Computers use binary system instead of this decimal system. So computer scientists need to know how this works. And there is also a hexadecimal system. Similarly, you can define system of the base length that you want. And simple number theory concepts are used for understanding such systems. The problem-solving processes of discrete mathematics, they are basis of modern computer engineering. They power both simple and complex disciplines such as computer architecture, functional programming, distributed systems, machine learning, artificial intelligence. So all those have base as discrete mathematics and algorithms. And as a computer science professional, you might use this like discrete maths to test out simple algorithms also, test out multiple algorithms also, and to have an understanding which is going to be most efficient, right? Meanwhile, the logical thinking you develop as a discrete math student will help you to approach programming and develop tasks more methodologically. Okay. Then statistics, very important component. This is a subject in itself, and This allows computer programs to deliver accurate generalizations and predictions based on the available information. Okay, this is quantitative analysis, you can say. Understanding statistics can make it easier to grasp concepts of data mining, machine learning, future modeling, speech recognition, user responsiveness, computer graphics analysis, etc. And all this is used for, like, for example, artificial intelligence is something which is talk of the town, and you also must be knowing whereabouts of it. So you feel it in daily life. You see some advertisement, and then advertisements of that sort keep coming your way, right? So this is not some coincidence. There is a mathematics related to this. So that simply depends upon what level of understanding you can have to understand why is this taking place, how the metrics are used to define different parameters which judge, where are the potential customers. So that is the kind of work which this does. Calculus, there are two types of calculus, I would say: integral calculus and differential calculus. So a very basic subject that you must have taken up, of course, if you're a math student. Together, these disciplines will help you to figure out rate of change, which is an important ingredient in algorithms and programs. And differential equations particularly are very important. They calculate how something changes and how fast that happens, so as computer can predict future outputs. Okay, so this will help in designing simulations, improving problem solving programs, creating effective algorithms, and developing accurate graphs also. Okay. Then very important and very interesting is that mathematics is also used in forensic services. In the crime control, you can take help of mathematics. In fact, nowadays, a subject called forensic mathematics has also come up, where you study mathematics which is relevant to understanding the detection of the criminal, or at least having some sort of indication towards it. Okay, so this is one of the most important technique used in forensic discipline to solve problems related to uncertainty, probabilities, and interpretation of results, which may be indirectly helpful to come up with a predictable solution. Okay, so let's see this divided into three parts. One is trigonometric measurements, like, so I'll give you one example each to have what kind of information you can have. But before that, I would like to say forensic mathematics is defined as application of principles and methods of mathematics such as trigonometry, probability, statistics, graphical representation, and many more for the determination of various mathematical quantities which are considered to be part of different methods and tests used to analyze the evidence related to a crime. So that is how it works. And in fact, you can also say that forensic mathematics is application of mathematical concepts, right, in the field of forensic science. So, and this is, of course, for the purpose of solving crimes. So let's see some instances where you can more appreciate the subject. So suppose one person from the audience claims that he has been hit by a cricket ball thrown by the suspect, and test results show that initial speed could be a maximum of 50 meters per second and not more than that. So if the suspect was 150 meter away from that person, is it possible that ball hit him? Okay, so what we do is, using this maximum range concept, using this projectile motion and maximum range concept, we can calculate what is the maximum range, right? In this case, it turns out to be like if the audience is at 150 meters, then initial speed would have been 38.34 meters in this case. Okay, and here the speed is 50 meters per second. So that way, yes, probably that ball could have hit him. And similarly, it could have been possible that if he was in range beyond this, we would have said that no, the ball could not have hit him, right? Then there is another example that I can talk about. Suppose a bag has been stolen from a desk drawer in the office where there are 30 people who are present, and assume that it is confirmed that someone within the office has stolen that bag. And while stealing the bag, suppose the thief got injured and some drops fell off. Okay? A blood drop on the desk is found to be of group A now. So there are 5 people with A blood group in that office. Calculate the probability of selecting someone at random who is guilty and has A blood group. So this uses your simple Bayes theorem and high school concepts of probability to compute the probability of this thing, and then one can conclude something. Maybe not too definite in this case because it is probable case. So this is how you can, this is one example where you can use this. Now, this is clearly evident that mathematical calculations will have a wide range of applications. In fact, there is one more application which I have not mentioned here in my slides. For example, if a thief's car was being chased and on the number plate was not well recognizable. Okay, suppose it was blurred image that could be taken. Then differential calculus can be used, differential equations can actually be used to have a finer picture and to be able to detect the number plate. Okay, and again, of course, the mathematics is behind that. So it is serving society in multiple ways, right? And particularly for science aspirants, I guess that most of you are science students here. So particularly for science students, I would say that mathematics is essential. You cannot really go ahead without having some high algebra, some high level mathematics. But because of the time constraints that we will be having and the more of the things that I want to talk about, I will just take one application each for physics, chemistry, bio, just to show you the relevance and which are more, understandable for you. But there are numerous applications. In fact, there are books on each of the topics that you can find, how mathematics is related to physics or chemistry or bio, or what are the applications. So I chose to talk about wave equation in case of physics. So waves, a layman would see them as either beautiful, or at times they could be sort of violent, or you can say destructive, which could be hurting manpower and creating loss. Then somebody can also see it for energy harvesting, okay, the waves that are. So what level or what speed of waves are beautiful, which of them are destructive, what is to be expected for energy harvesting, what is the best location, okay. So all these come via wave equation, and of course their solution, their optimal solution, or their the closest solution given certain parameters, they use the tools of mathematics, right? So that is one example. Of course there are many others. If you talk of chemistry, so chemists molecule structure, right, that you must be familiar with. So that classifies chemists, what do? They classify molecules according to their symmetry, right? And symmetry considerations are applied in orbital calculations, and these orbital calculations, they are associated to determining the energy levels of atoms and molecules, right? And in the study of molecular vibrations also. So what is the symmetry group of the molecules that you talk of? For example, if you talk of ammonia, the symmetric group of pyramidal molecule, that has symmetric group D4. Now D4 is an algebraic, is a group in algebra which has 8 elements, and it has certain structures, some rules which it satisfies. So this is associated to the structure of ammonia, right? And similarly, like mineralogists use a lot of mathematics. The crystallography is a branch of chemistry which is associated to mathematics, and this is also connected to representation theory, which somehow happens to be area of my research overlapping there. So what are the possible symmetries, or what are the possible things, and how, what kind of energy levels to expect? All these, this is involving mathematical concepts. Okay, coming on to biology. When we talk of biology, we see already the application of biology in medical sciences, right? A layman will always, though flora fauna is a part of biology, and of course a very broad area of work, but then one thing is medical science associated to it. Now, when you talk of medical science and mathematics connection to that, one thing is a very basic thing. You know, you have apparatus, you have equipments, you have machines. They are backed by mathematics, and then all sort of testings, all those the various tests that you need to have understanding of a disease or diagnosis. Mathematics is involved there also, right? And not only that, this DNA, or this heart valve, the construction of that, the shape of that, or the artery blockage, as I also mentioned earlier. So the flow of liquid which has to be there, how much volume shall be passing through an artery, what should be the speed of this, all these kind of judgments are used to diagnose uh, if there is some problem, and up to what level. Okay, up to what level. And then this DNA, this is strongly connected to a subject of mathematics which is called as knot theory. Okay, so as I said, of course there are many things, but I just wanted to bring one to your picture, or one to your vision, so that you are convinced with my version of mathematics and its importance. So if you are a mathematics aspirant already, what I would like to suggest you is be involved. This subject is really important. In fact, UNESCO has related mathematics to development and sustainable goals. International Mathematics Day is celebrated on March 14. This is also called as Pi Day. March 14 is third month and 14th date. So 3.14 is the usual estimated value of pi that we take. And this is how the name Pi Day is referred to. And the themes that they have in this direction are generally which point out towards development and sustainability goals, right? So this is for a bigger goal, bigger achievement, rather than just studying. There are a lot of applications which can benefit society. Okay, that is one thing. The other thing is mathematical research. There is no end to it, no contentment that you're going to stop at. There is no saturation, I should say. There are endless topics under mathematics, endless subjects, I would say, under mathematics. It could be history of mathematics, it could be something like mathematical biology, it could be something like mathematics and artificial intelligence, or calculus, algebra, analysis, the basic subjects that you already know. So there is a wide range of topics that you can choose from, and as per your interest, you can go as much ahead as you want to. There are several open problems, there are several conjectures, and the mathematical research is something like, at times you see its direct applications, and at times it takes years to realize, to appreciate the value of some results. Okay, that is there. So be involved in mathematics if you are a mathematics aspirant. There are a lot of national and international quizzes and competitions going around the world, not just within India, but across the nations also, almost at every level, right? So just choose for yourself which suits you, just be involved in that. And there are a lot of funding agencies which support mathematical research. I mean, the all the funding agencies definitely support STEM fields, and there are also additionally for mathematics. For example, National Board for Higher Mathematics. So they do give you funding for higher mathematics if you are, really aspirant of this. And if you are not, that could be a case, and that generally is. This is my reading. Okay, so in that case, I would like to talk more about this subject. Let's analyze this subject. So, general judgments or myths which are associated with this subject is that this is scary, this is frightening subject. बस mathematics से डर लगता है, everything else is good is something which I hear very often from the students, right? Then they also say, to learn mathematics, you need to memorize so many things, you need to cram so many formulae, techniques, and results, which is very difficult. Then people also say that mathematics is not science, and of course it's just a tool, it's just a part of learning. So we'll just learn that part of mathematics which is needed for us. Then people also say it is so unreal, so abstract. We never see sine theta, cos theta in our real life, things like that. And people also say that this mathematics is not a career option. Okay, so let me now give you my take or my viewpoint on that. I would say this is I'm sorry. Okay, I would say this subject is quite joyous. This is quite engaging and fascinating. This is scary or frightening only if you're not adapting the right methods. You need to have clear understanding of the subject, and then you don't need any cramming at all. In fact, let me tell you very honestly that the only reason for me opting mathematics or liking mathematics was that I had a very bad memory. So there was no cramming which was needed here. I could just understand and apply the things. So it's only logics that you need here. Okay. And this is at the intersection of all sciences, and hence it is a most important one thing. Secondly, it's a wholesome subject in itself, right? This is independently a subject which is not dependent on anything else. It applies to various other subjects, but then it is not just a tool, it's a subject, it's a discipline in itself. And this is not unreal or abstract. Everything comes naturally here. One just needs patience and some time, some devotion to understand where that concept is coming from or what led to the origin of that. This is very natural. In fact, mathematics is called language of nature, right? And this is base of all careers. I've given you several instances justifying this thing, and you can also realize that no career option, various career options, they just you just cannot get away without understanding mathematics. So in mathematics itself also there are various career options which you have, and there is a lot of scope of progress. Okay, so concluding to what I began with, mathematics, why to study, and I guess now you will have more relatability to the things that I'm going to say after going over the things that I spoke. Firstly, that it has applications in daily life. A very important application of this is that it develops logical and rational thinking. Mathematics is quite definite. It's either yes or no. Okay, so there is a definite kind of conclusion drawing that you can do using mathematics, and it improves your decision making. This is vital for most careers, and this gives various career options. This is a very vast subject, never ending learning process, and this is important and useful for everyone, especially for students, and also if society has to sustain and develop, mathematics has to be there, right? And just ask yourself, if you are an aspiring scientist, can you be a scientist without learning higher mathematics? That's not possible according to me. And why do I study mathematics? Simply because I find it mesmerizing. I've always liked this subject. Of course, I'm supposed to, but I also love to study mathematics. So it is like I'm being paid for something that I enjoy. And not only academic recognition, it has given me a very important lesson for life that every problem has a solution. It may take some time or a while to reach to that solution, but you need to be consistent, you need to be patient to reach to that solution so that you will be able to appreciate it. And there I stop in the concern of time. And my thanks goes to INYAS, to IIT Roorkee, my host institute, and also to TST Inspire. Over to you, Bindya.
Thank you so much, Suganda. It was really an interesting talk. Though we know what mathematics, what kind of role mathematics plays in our day-to-day life, but few things which you told in your talk were really interesting. I mean, I didn't know face recognition and everything. It requires some kind of mathematics. And then when you talked about using differential equations for differential calculus for this number plate recognition, that was something quite interesting. I really liked it. So now, before we head on for questions, I would like to have a group photograph of, because towards the end people start leaving. Before we can ask more questions, I think if we can have a group photograph, and I request everyone to switch on their cameras. And if Suganda, you can stop the screen share.
Yeah, I'll just stop sharing the screen. Yeah.
Yeah. Okay. So if everyone can please switch on their cameras, I can take a picture quickly. More people. Still, a lot of people have not switched on their cameras. I request everyone to kindly switch on their cameras just for 2 minutes so that I can take a group picture. More, please. All right, so I'll take a picture now. 1, 2, and 3. Great. So now the room is open for questions, and I encourage students, all other attendees who are in Zoom, they can ask their questions either by typing them in chat window, or they can raise their hands and we can unmute them. Okay, meantime, they are asking their questions or making up their mind to ask questions. Suganda, I would like to ask, what made you said first reason you love mathematics is that you had a problem memorizing problem, and yeah, but what made you, was mathematics your first choice for your career?
Yeah, so the time when I was supposed to choose from, PCB or PCM, by that time I was good at mathematics and it was a clear choice. And during my time, it was engineering which was at its peak, everybody wanted to be an engineer. And so was my case. But then over the 2 years, I realized I enjoyed mathematics more than the other two. And in fact, I also got this position in engineering. I could have opted for that. And I actually had hard time convincing my parents that, this is not what I want to do, but I want to do mathematics. So one thing was that, teaching was something which was luring me. And this subject is something like you can just read on at your pace. And there are so many things that you can explore. So that was a natural inclination. And of course, as I mentioned, that's a very true thing that I cannot cram formulae or anything. The basic trigonometric formulae which were there, which are taught at high school in +1 and +2, I sort of used to always derive them in my mind to be able to apply them somewhere. So that was how natural it was for me. It was very I always had to have some understanding, some basic information to be able to draw some conclusion rather than, okay, this is the formula, you apply and you have a solution. That was never my approach. And I guess that is what led me to have understanding of how good this or how fascinating this subject is. So yeah, like for example, a very simple thing. The volume of cylinder. Okay, so just imagine you have some coins. So the area of coin is pi r square. You keep piling them up. So this goes height wise. So pi r square times h. That gives you the cylinder. So such kind of depictions or illustrations or understanding, they help you, realizing that everything is so natural there. And similarly, there are hundreds of examples which can be talked about.
Yes, I think visualization is the key, not only for mathematics, but for almost every subject.
Everything, yes. It begins from imagination. Then you have some hypothesis, then you have some testing, and then you have some conclusions, and then you have verifications. But it all begins with imagination. That's the key.
One question I have is, like you talked about different streams where mathematics is useful, like forensic sciences you talked about. Do you think a mathematician is directly recruited for such career options, or they need to build up their profile more in other areas as well?
So it depends. It depends. For example, some people can train mathematicians according to their needs. And sometimes in mathematics, you do some research showing explicitly, okay, this is the application. So that way you are recruited. So it's a dual kind of thing. There is no fine line that you can draw between the two things.
All right. There's a question in chat window by Chinmay. He says, first of all, he is complimenting that it was a very interesting talk. And regarding mathematics and architecture, why did Egyptians choose to build giant pyramidal structures? What benefits do a pyramid shape provide for their purpose of preserving dead bodies and building tombs?
Yeah, of course. So such kind of reasoning, such kind of curiosity is something which initiates, the understanding of these things. So thank you very much for that question. But sorry to disappoint you, I do not have a clear answer to this. Like, why is this shape for this thing? But there is a reason for everything, as I said. For example, this Eiffel Tower in Paris, which is now monument of tourist interest. Actually, it was not built to be there forever. It was supposed to be there for some time. It was supposed to be a temporary building. And there was a logic or reason behind why it was built in that shape. So similarly, such things are there. One needs to explore more and get to the reasons. Sorry, I do not have a ready answer right now. But yeah, I would like to look into it, and you should also just Google search and see what is it. But this curiosity is something which initiates, such kind of thing. So yeah, career options in mathematics other than academics. So as I said, it depends upon so suppose if you don't want to be in teaching line, right? And then mathematics are recruited by, for example, DRDO. They recruit mathematics, and in fact you can go via this GATE exam also for that recruitment. Then there are banking exams that everybody does at basic level where they can opt this thing. Then for all these like for weather predictions, as I told you, for all these kind of applied forms, they need mathematicians. So all those kind of options you can explore into what sort of training is needed to be able to enter those fields. So it is not that you need to have whole understanding of mathematics. A part of it which is applied to certain area is something that you can work upon and go ahead. Okay, so it can be actuarial sciences. So this is one thing which is luring so many people because of the because of the good pay packages that they provide. So in actuarial sciences, they use basic to high level mathematics for this risk management, for these policies and everything. So that could be one career option, and it's a very luring career option, this being an actuarial scientist. And like that, there are various other options that you can explore.
There's another question. She's a student at our university at GNDU. She's a mathematics student. So she is asking how to avail a scholarship if she wants to further study mathematics at
Right. So it firstly depends upon scholarship at what level. Okay. So if you are a graduate student, there are scholarships of that form. If you're a postgraduate student, according to that. And I'll talk about research fellowships also. In the meantime, there's mathematical Olympiads and everything, all those things. Then there are competitions. If you keep an eye on the UNESCO site, there are competitions on Pi Day which are being conducted. There are activities which are conducted in those themes. So you can also participate in those themes. That is also one thing. And then scholarships at the level of PhD, you have various fellowships. Okay, you can apply for them. For example, NBHM, CSIR, UGC. Then at the postdoctoral level, you have DST and PDF. Then there are fellowships given by CSIR also, again by NBHM also. Then there are some women scientist schemes, and internationally also there are various schemes for women in STEM. M in STEM stands for mathematics. Okay, so not only for women in STEM, it is in general for STEM, but especially for women in STEM also, there are various options that you can get into. And if you have some inclination towards computer science, then it sort of multifolds, because there are various scholarships for the computer programmers along with the ones who do mathematics. So yeah, there are numerous, it depends upon at what stage of career you are and what kind of scholarship you are eligible for. Okay. Generally, it's an entrance test, and in most cases, it is also followed by some interview. That is the thing.
Thank you so much. Another question, like regarding group theory. We know group theory is applied to a lot of streams, like in physics, we use that in particle physics, astrophysics. The question is how we can apply group theory in our day-to-day life.
So one thing is symmetry that I told you about. So you just play around with a triangle, I would say. Triangle or a square, right? So just try to see in how many ways you can move that triangle in whatsoever way you want, rotation or flipping or whatsoever, to get a triangle back. So this ABC could be ACB in your changed position, and just try to play around with how many possibilities are there. So all these possibilities will form a group. Now, forming a group means you have, so for the students who may not know group at all, so the binary operation means you do any two such transformations, you'll get back another transformation, right? So that is the kind of binary operation. Then if you have some transformation done, there is always a way to go back to the previous one. So that is sort of inverse that you can apply to this. And similarly, all other properties you can understand. Similarly, you can do such a thing with square or any other, polygon, regular n polygon, to realize the group, which is dihedral group that we say. That is one way. The other could be to describe. So representation theory is something I wouldn't like to talk. Maybe it will be a little too much. That is also where group theory plays a good role.
Magicians, they use group theory a lot.
Sorry?
Magicians?
Yes, of course. So all these games, card games, there is a lot of mathematics involved in that. If you do this, if you do that, this function, then inverse of this, so there is actually no magic. There is actually no magic. It's only logic behind that.
It's only science and mathematics.
In fact, I did not cover up. I wanted to, but then it was getting a little too elaborated. Mathematics has a lot of role in the beauty also, in the symmetry, the golden ratio. So why is something more beautiful than the other, why it is more appealing to eyes, that also has a mathematical justification. A simple question, just try to Google search it. Your television screen, that's always in a rectangle shape where length is this way and then you have breadth this way. Why isn't it the other way around? Why isn't that appealing? So all these things have logic and mathematics giving a justification to such things.
Suganda, there's another question from a mathematics student. Career options in statistics and which institutes are best for masters in statistics?
Well, there are some dedicated institutes in India. For example, ISI, Indian Statistical Institute. You have one in Kolkata, you have in Delhi also. But then there are, I mean, it's not restricted to these institutes only. And these are just some names that came up to my mind. There are various institutions across the country which are related just to mathematics. Some research institutes that I would like to point out, they're not just for statistics or something, like for mathematics, I'm saying. HRI, Harishchandra Research Institute, CMI, Chennai Mathematical Institute, IMSC, Institute of Mathematical Sciences, again in Chennai. Then you have TIFR, Tata Institute of Fundamental Research, known to be the best, the most premier one in the country. Then you have ICTS, same as TIFR, I mean, associated to similar. Then you have all IITs where you have mathematics department to do researches, ISERs, and then there are state and central universities and colleges, of course. So it's not restricted to one place or, you know, a couple of places where you can do this research. And so, yes, you can, I mean, again, it depends upon whether you want to pursue it on graduation level, post-graduation level, and further. And regarding career options in statistics, so statistics is like sort of data analysis that you have to do. And again, getting into research or getting more deeper into it, you can find various applications. For example, you have a data, you analyze it, and this is something which is done by biologists the most because they have a lot of samples to work with, right? So this comes at the intersection of the two things. So how you apply statistics to what kind of conclusion do you need, those kind of things, and what technique will be best. And in statistics, like what kind of technique is best for what kind of population, right? What is your sample size? So all these things that needs your understanding as a mathematician or as a statistician. And if you're able to provide such solutions to people, then rest everything, I mean, calculations can be taken care even by computers. Okay, so it is the base that needs understanding that is there.
Very, very interesting. Thank you so much. I'll take, if you don't mind, we are already about time, but there's one more question. I would like to have this last question before we end the meeting. Is that all right, Suganda?
Yes, I can read that question also, so we don't need to waste time on reading that. So if an undergraduate has a poor financial background but want to pursue further in mathematics, very good question, and thanks for bringing that question. Let me tell you myself, I did not spend a penny on my education from my pocket after my +2. So my whole education, like whatever nominal fee I had to pay at Punjab University, more than that I was getting as a scholarship from NBHM, and there onwards it was always the fellowships or scholarships that I was getting. So, and in fact, in general also for all the science streams, it's not the money which is hindrance. In fact, if you want to pursue, if you have a strong will, this is, I would say, more economical than most professional courses, I would say. Okay, so in fact, in my outreach, I point it out to most students when I go to rural area, because one inhibition that they have in mind is science can be opted by people who are good at financial level. Okay, so most of them, they do not opt for career in science because they think they have to pay bulky fees, because it is the medical, like being a doctor or an engineer is the only career option that they see. So that's why I'm saying thanks for bringing out that question. It's not that you need huge finances to study mathematics. Not at all. That's not there. And that also brings me to one important point of mathematics. when you get into research also, you'll realize that your colleagues in other sciences will always be struggling for funds. But whereas for mathematics, you really don't need funds. You are always having more of funds. So this is least expensive subject, what I would say. You can just work on pen and paper to work on mathematics, to draw beautiful results. You should be fond of reading mathematics, to learn mathematics, to be able to produce mathematics. That is the thing. So
Yeah. Harman, there are also something called KVPYs.
yes, I should have mentioned that. So they also provide you good fellowships, and Inspire has various components. DST Inspire has various components, so at various levels you can. In fact, there was shortage of time, but at times I have given a lecture on the various career options or the possibilities in mathematics. Maybe I'll share YouTube link of the lectures which I've given already, and yeah, or maybe some other time we can discuss about that.
Yeah, I think if you can share the link, that will be really great.
Yeah, I'll do that. I'll do that.
But I can sense your excitement for the subject you are into and your love for mathematics by the way you have been answering all the questions. So thanks a lot, Suganda. It was really nice having you here, and probably we'll contact you again sometime for more mathematical information in
I'll
future.
be pleased. Thank you, Bindya, and thank you, audience, for being patient to listen to me and for putting up nice questions. If you ever want to talk more about it, you're most welcome to interact with me anytime.
Thank you so much.
Okay, thank you. It was great being here.